Hey there, Mustangs. Rosenwald here with another edition of How to Do Things. And in this edition, we're going to be working on how to graph and solve quadratic inequalities. Now, there's an algebraic way of doing this, which requires a whole bunch of little steps. But then there's another approach where you can just kind of graph it and look at the graph and go from there. So let's take a look at this one first. Anytime we're doing these, generally you want to take this and do a comparison equal to zero. So if it's not equal to zero, what you're going to want to do is actually take it and get it so everything is on one side of the equation and have it related to zero. Because then what we're doing is, in terms of zero, we're looking at above or below the zero, and we're actually looking at positive versus negative. Super easy, right? So let's take a look at this first one here. It says write the interval over which x squared minus 2x minus 3 is greater than or equal to 0. Let's just assume an inequality first as an equation and see if we can solve for when it would actually be equal to 0. If I factor this, we have x minus 3 and x plus 1 is equal to 0, so we get x is equal to positive 3 and negative 1. Now this is where it is actually equal to 0. Okay? And what this does is it creates these what we call critical points at 3 and at negative 1. It's actually equal to it right here. So those are critical points. What that means is somewhere in the middle of all this, we're above 0, somewhere we're maybe below 0, somewhere we're above. Sometimes we're all above, sometimes we're all below. You don't know until you know, or sometimes you just do. And so what we're going to do is we're going to test out some values. Choose a value, any value you want. I'm going to choose a value to the left of negative 1. We're going to test it and see what happens here. So if I go negative 1, let's go ahead and test out negative 10. Okay, now I don't care about the exact number. I just want to know, is the value that we're looking at greater than 0, equal to 0, or less than 0? Okay, if it's a positive or a negative. So let's take that negative 10 right here, and we're going to put that negative 10 in for x in these two spots. So if that's the case, I'm going to have negative 13 times negative 9. Okay, because negative 10 minus 3 is negative 13, negative 10 plus 1 is negative 9. If I multiply a negative times a negative, we end up with a positive, and a positive is actually greater than 0. So it is positive, so we would say, yes, this is where my answers are going to reside. This is where it's going to be greater than 0. If I want to test another point in between the 1 and the 3, let's go ahead and say we test this 0 right here. Same exact idea. Let's take 0 and we're going to put in for this x right here and for this x right here. 0 minus 3 is a negative 3. Okay. 0 plus 1 is a 1. A negative times a positive equals a negative. And so we end up with a negative here, and that is not greater than 0, so no. And then we're going to go ahead and do a value to the right of 3. Again, let's choose something big. Let's say 10. If I put in a 10 here for this value, 10 and 10 for those x's, 10 minus 3 is equal to 7. 10 plus 1 is equal to 11. And 11 times 7 is a positive, right? And so that's going to be yes. So now if I was to say, where are my answers from this? We would say it's going to be from negative 10 to negative 1. And we could say inclusive because we have an equal sign there. Okay, so it's actually going to include the negative 1. And then we say skip the middle here. And then we're going to go from 3. It's included because of that greater than sign, or equal to. And then we're going to go to the right forever, to infinity. Okay? Now what does that question, just that portion, look like in a graph? What I did was I graphed that x squared minus 2x minus 3. And I said, let's compare it to where it's equal to 0. Well, at 0, what we find is that these are my zeros at negative 1 and 3. And then follow along with me here. What's happening is as I move from left to right, you can see from my graph that what's happening is I'm going down right here. I'm going down, I'm going down, I'm going down. And in this area, I'm positive. I'm above the x-axis. And then what's going to happen is I'm going to go ahead and switch, and now I'm going to be over here. I'm negative. I'm actually under the x-axis, okay? And then I'm going to continue back on to the right here, and we're going to be above the x-axis, and so we're positive again. So if we look at this graph again, right here and right here is where we are positive, and then right in the middle is where we are negative. We're above the line and we're below the line. And so if we look at that, the inequality that's going to go into this part, the interval that's going to go in for this part right here is going to be from negative infinity to negative 1, and it's inclusive, and then from 3 to infinity to the right, because we're going this direction and we're going this direction with it. Okay, so that's how you would analyze this from a graph. And those are the same inequalities that we have up above there, or intervals that we have. So now for the second one, if I was to say, well, let's go ahead and look at the interval for which it's actually, instead of being greater than 0 or equal to 0, let's look at when it's less than 0. Where's a negative? Well, if I look at my picture here, we can already see where that answer is. We look at right here where it cuts off, and right here where it cuts off at 1 and 3. And between 1 and 3 is where you can see my graph is actually under the 0. So the interval for this is 1, 3. Now, because we have a less than sign, we don't have the equal, we just have the less than sign, we do not include those values. And so we go ahead and put 1 and 3 for the interval. All right. This concludes the video for how to solve and graph quadratic inequalities. You're going to see a lot of similarities between this and then now when we do projectile motion, okay? Take care and go Mustangs. Oh, don't forget to like and subscribe.